Magandang araw po sa inyo lahat, and this time we're going to design the wooden beam for bending. So this is for the timber design for architecture, and I am Architect Ryan G. Abella, your lecturer. Okay. Ang reference po natin dito ay ang Simplified Engineering for Architects and Builders by Tripini and Ambrosi. Okay. The design of a wood beam for strength in bending is accomplished by use of the flexural formula. So the form of this equation used in design is S is equal to M over FB, where M is the maximum bending moment, FB is the allowable bending stress, and S is the required section modulus or the required beam section modulus. Beams must be considered for shear, deflection, end bearing, and lateral buckling, as well as for bending stress. However, the common procedure is to first find the beam size required for bending and then to investigate the other conditions. Such a procedure is as follows. So first, we're going to determine the maximum bending moment. Second, select the wood species and grade of lumber to be used. Number 3, determine the basic allowable bending stress. Number 4, consider appropriate modifications for the designed stress value to be used. Number 5, using the allowable bending stress in the flexural formula, and then find the required section modulus. Select a beam size from the table, and then number 7 is we're going to investigate for applicable concerns other than bending. Okay, so we have a sample problem. A simple beam has a span of 3 meters and supports a uniformly distributed load, including its own weight of 8 kN per meter. So we're using the Yacal 80% stress grade, and we're going to determine the size of the beam with the least cross-sectional area on the basis of limiting bending stress. So the allowable bending stress for Yacal 80% stress grade is equal to 24.5 MPa or megapascal. First, we are going to determine the maximum bending moment for this condition. Okay, ang kanyang formula po is M is equal to WL squared over 8, which W is the load or the uniformly distributed load, and L is the span of the length of the beam. Okay. So moment is equal to 8 kN per meter, that is our W, and times 3 meters squared. 3 meters is our L squared, and that is divided by 8, and our maximum moment is equal to 9 kN meter. So the next step is we're going to determine the section modulus. So which S is equal to M over FB, which M is our moment or maximum moment, and FB is our allowable bending stress. So our moment is equal to 9 kN meter, and our FB or the allowable bending stress is equal to 24.5 MPa. MPa is Newton over millimeters. Magkaiba po ang units ng moment and allowable bending stress. Ang moment po, maximum moment is kilonewton meter, and ang FB is Newton over millimeter squared. Now we are going to convert kilonewton to Newton and meter to millimeter. So if we're going to convert that, times na po natin ng 1,000 ang kilonewton to Newton, and another 1,000 for meter to millimeter. Okay, and that is equal to 367,346.94 millimeter cube. Okay, so this time we're going to convert millimeter cube to inch cube, kasi ang table po na gagamitin natin to determine the dimension or the size of the beam is naka-inch po siya. Okay, so this time we're going to select 5 sections, which where section modulus is higher than the actual section modulus, which is 22.42. Okay, so kung makikita natin sa table, ang next to 22.42 inch cube is 27.73 inch cube. Ang area po is 30.25 ang size of the space. Okay. So next to 27.73 is 30.66 inch cube. So an area of 25.38 and a size of 4 by 8. So next to 30.66 is 31.64, having an area of 16.88 inch squared, and ang size po is 82 by 12. And next is 35.65, having an area of 23.13 inch squared and size 3 by 10. Then the last is 43.89. Ang area is 19.88. Size po is 2 by 14. Okay. So this time we're going to select. Going to select the least cross-sectional area. Okay? So dito po tayo titingin sa area. Okay. So kung makikita natin, ang least cross-sectional area is 16.88, pagkatapos susundan ng 19.88, and then 23.13, 25.38, and 30.25. So ang hinihingi sa problem is the least cross-sectional area. So, pinaka least po is ang 16.88 inch squared. So we're going to use 2 by 12 inch na dimension. Okay? So dyan po nagtatapos